What's up, everybody? This is Aircrete Harry, and today I'm going to perform the second thermal battery test. In my last video, I took some different samples of Aircrete rock, cement, piece of iron, aluminum, and I put them in a fire to let them absorb heat to see which of the samples would retain the heat the longest. And really, the idea started from the rocket mass stove heater that Darwin Honeydew Carpenter built, which blew me away at how it retained the heat. And until that test, until I seen the rocket stove myself in person, I didn't think Aircrete would work as a thermal battery. And so anyway, the first test that I did, I put these samples in a fire pit, and really there was only heat hitting the samples from one side. So in today's experiment, I want to put these samples in the oven for an hour on maximum, whatever it is, 500 degrees, and let them absorb the heat all the way around. And then I'll take some thermal flare images and see which of these samples retain the heat the longest. So in my last test, the sand cement mix that I had retained the heat the longest. The Aircrete was really good at insulating. It cooled down, but I didn't have it in the same type of conditions like the rocket stove or the forge Darwin built. So this is my idea of testing it to see if it will absorb more heat in this way in the oven, and then I can really test its thermal battery properties. So I have 3 samples here. This is just a regular Aircrete. This is a new paper Aircrete blend that I did, and this is the Epic mix. I don't know if all of these are going to fit in my oven, so I may just do the 2 Aircrete. This new paper Aircrete and the regular Aircrete sample that I have here. And I think this is the only just Aircrete brick that I have available right now. So I'll just be putting these 2 in the oven for 1 hour, and I'll take them out and I'll see how long they can retain the heat. And I'll use the thermal imaging camera to look at that. Anyway, we'll be into the oven next. Okay, so my Aircrete sample's in the oven now, and I'm going to leave it in there for an hour, maybe a little longer, and then I'll remove it and we'll look at it with the thermal imaging camera. Okay, everybody, it's been more than an hour now, and I have my Aircrete sample has been sitting in here. The oven has 550 degree and I have it on broil. So I'm going to take this out, put it in a metal box I have outside to keep the wind off of it. And we'll take some thermal imaging readings on it. Oh, that's weird. It almost looks like the center of this brick is still cool. That's very interesting. I know this brick is fully cured and dry. That's an interesting reading. Alright, I'm going to take this outside and we'll see how this looks. Very interesting. Okay, so I got my Aircrete sample out here. Let's see. And this time, okay, I got my Aircrete sample out here. It's in this metal box out of the wind because it's very windy right now. And the time now is 12:20 p.m. Let's see. Right now, this sample is reading 287. This is up on edge. I'm gonna put this out here. Let's see what kind of reading we got. I'm getting 30. Trying to get the hottest spot. You guys can see the numbers change. looks like 312 was the hottest reading I just got. I'm gonna flip it to the other side. See what reading we got here. We'll just call that 300. Yeah, I'm getting like 390. I'll flip it back over. The other side seems to be, hotter. Now, another thing about my Aircrete is it's a different recipe than the Aircrete Honeydew Carpenter used in his rocket mast heater stove. And I think his maybe have bigger air pockets or something. I forget exactly. It's not the same Aircrete mix. I can say that for sure. Alright, so anyway, the test here will be how long can it hold the heat. And I'm going to close this box so it's not affected by the wind, because it's a very windy day here today. Seems to have gone down a lot already. Well, I also have another Aircrete sample in the oven because I couldn't fit two of them at the same time. And the other one is my paper Aircrete mix, which has only been curing for 2 weeks, or actually less than that. So it'll be interesting to see how that turns out. Okay, anyway, that box is just to replicate being indoors out of the wind. And as I mentioned, it was 2:20 when I last called out the time. I'll come back to this in a half an hour and we'll get a reading on it. Okay, so about 15 minutes has gone by. Let's take a look. We can see right now I'm getting a reading of 157 degrees, 158 and one hot spot there. I saw 160 degrees. So it's definitely cooled down since 15 minutes ago. Now let me flip the sample over and see. Actually, I'm going to stand it on the edge and see what the edge is reading. I'm getting about 160 on the edge. I'll flip it over on the other side. I got 200. Now that's interesting because this is the side that was touching the steel, the floor here. This is all steel or sheet metal. Sheet metal similar to the rocket stove. And they seem to help it. We may have found what helps it to keep heat. One more time. This side of the brick is reading cooler. Okay, so that's very interesting because we were at 300 degrees when I first placed this Aircrete sample into this metal container. This is, you can see here, it's just a big metal box. This is the box my my shipping container tarp came in. It's made of sheet metal, and I had it in here right out of the oven. I put it in this box to keep the wind off of it, and you can see it's been cooling down the entire time, and it hasn't been that long. So I think a big factor in the Aircrete retaining the heat, at least with my bricks, with my Aircrete mix, the size of my air bubbles in there, and this blend with just being Portland cement and shaving cream consistency foam, is begun to cool down a lot already compared to what it was before. Now again, what I have noticed is the side that's contacting the sheet metal is hotter than this side. This was the hottest side of the brick before, and the side that's been touching the sheet metal, I'm trying to get focused here, there we go, has actually also cooled down already. It's cooling down a lot, from 300 degrees in about 15 minutes. It's calibrating. Let's see, I'm looking for the hottest spot. Yeah, it's cooled down a lot. So well, anyway, this is one Aircrete brick. Next I have a paper Aircrete brick that's in the oven right now. Again, it's not fully cured yet. It's only been curing for about, I don't know, maybe 10 days or so. So it may still have moisture inside of it. It'll be curious to see what happens when I take that out, and that brick is next. But as far as this brick, without being encased in any sheet metal like the rocket stove and the forge were, it seems to cool down pretty quickly with my Aircrete mix. I know Darwin uses a different Aircrete mix. He gets an open cell mix, and I think that's what he's using. I'll have to confirm with him if the Aircrete he pours in his rocket stove and riser are the open cell mix that he's developed. Anyway, I'm gonna leave this one in here, and I have about another half hour, I think, before the other sample is ready to take out of the oven. Okay, so here we have the paper Aircrete sample, and let's get a reading on this. This was also in the oven on broil mode for over an hour. Wow, that didn't absorb much heat at all. That's reading 150 degrees. I see the corner here is showing a little hotter, 168. I'm gonna flip that piece over. Let's do it on the edge first and see what we got. I'm getting 158 degrees. Backside here. Hottest spot is reading 170 degrees. Surprisingly, the Papercrete absorbed less heat than the just Aircrete sample. So this was the Aircrete alone, which was up to 300 degrees after an hour, and this is the paper Aircrete, which was 170 degrees. I guess one of the variables, as I said before, was this had only been curing or drying for approximately 10 days. And there's very good chance that the paper that's still inside of here still has moisture, so it hasn't fully cured. But I would imagine if there was still water in there, that water would get hot, and I don't know. This is I'm just winging it here, guys. I'm just trying to, you know, throw stuff on the wall and see what sticks. And anyway, the Aircrete sample that I made was 300 degrees out of the oven, and after about, I guess we can say 20 to 30 minutes, it cooled down to half the temperature. In fact, let's get a reading on it now, because it's been at least another half an hour since I took that Aircrete sample out of the oven. Yeah, it's cooled down considerably. It's 97 degrees. And I guess the real surprise for me is this paper Aircrete, not absorbing a lot of heat. I'm gonna have to try these tests again in the future, but for now, you can take what you will from this. I have to say, from my testing with these particular Aircrete samples, Aircrete and paper Aircrete, they are not good thermal batteries, these two guys. How much difference does it make to wrap a sheet of sheet metal around it? It could be making all the difference in the world. As I mentioned before, the forge that was made, I'm pretty sure had was tin or metal around the Aircrete, and the rocket stove definitely had sheet metal around it. And regardless of my test here, it worked. It worked in that rocket stove that Honeydew built. It was warm after 8 hours of sitting outdoors, and I'm just trying to replicate that thermal battery result that Honeydew got on his rocket stove, and so far I've not been able to. And as I mentioned, the open cell Aircrete may make a difference, as well as the burn chamber being a different material and being wrapped in sheet metal. Maybe all of those factors are what's needed to get the Aircrete to work as a thermal battery. Now, I believe what's really happening is, in both cases, the forge and the rocket stove, they get up to over 2,000 degrees. And that's the other, probably the big factor between the test that I've done with the oven and the fire pit, opposed to the rocket stove and the forge. Again, both of those systems got up to over 2,000 degrees. So perhaps that's the other big factor that I'm not able to replicate right now, because I don't have a forge or a rocket stove to test that. But I'm thinking that may be the big difference between being able to get this Aircrete stuff to work as a thermal battery. I think it needs to be in very high temperatures to have the time to absorb those high temperatures and then to radiate them out. That, besides the sheet metal and the firebox on the inside, must be the factor that I'm not able to replicate right now. And so anyway, I look forward to doing that. But from my experiments that I've done now, I realized that even at 600 degrees in the oven, it's really not enough to get my Aircrete sample and my paper Aircrete sample to a hot enough temperature for it to act as a good thermal battery. So I'm gonna have to do this test one more time. I guess I'll be making a forge and I'll be putting my Aircrete samples in a forge. I'll get it hot for an hour, and then I'll take it out, and then we'll see what kind of results we have as far as how well my Aircrete and paper Aircrete samples will work as a thermal battery. And I say that again, because I have a different Aircrete mix design than what Honeydew Carpenter has. So that's gonna have to be next. I guess I'm making a forge, people, and I'll do one of those propane forges. I'll use a bucket or something, put Aircrete in there, and blah blah blah. So anyway, that'll be next. And well, that's it for now. Peace.